Determine the values of P and Q if the asymptotes intersect at x is equals to 1 and y is equals to minus 3. So we are given the equation of f of x. It is said to be equals to a divided by x plus p plus q. In order to find the value of p, we let x plus p be equals to 0. But we already have the value of x. It is equals to 1 at the vertical asymptote. So 1 plus p is equals to 0. It is now easy to see that p is equals to minus 1. The value of q, on the other hand, is just equals to the horizontal asymptote, which is minus 3. P is equals to minus 1 and q is equals to minus 3. So f of x, now at this point, we know that it is equals to a divided by x minus 1 minus 3. In 4.1.2, we are looking for the value of a. How are we going to possibly find that? We're going to substitute the y-intercept or any other point on the graph. So the y-intercept, x is 0 and y is minus 5. So let's go ahead and substitute that in our graph. We're going to get minus 5 being equals to a divided by 0 minus 1 minus 3. If we take minus 3 to the left hand side, we're going to get minus 2 being equals to a divided by minus 1. It should be easy to see now that a is equals to 2. So that is 4.1.2. Let's go ahead and do 4.1.3. If f of x is translated to g of x, describe the translation from g to x. So let's go ahead and take a look at this. In f of x, we have x minus 1. In g of x, we have x minus 3. So when it comes to the x values, x minus shifts the graph to the right and x plus shifts the graph to the left. We had x minus 1. On g of x, we have x minus 1 minus 2, which is just x minus 3. So we have moved 2 units to the right. We can go ahead and write it down as moving 2 units to the right. On f of x, we have minus 3. On g of x, we have plus 3. From minus 3 to plus 3, you need to add 6. So we have shifted our graph 6 units up. So here we're going to have 6 units up. 4.1.4, write down the equation of the horizontal asymptote of g. The horizontal asymptote is this value here all the time. So for 4.1.4, we can easily say that y is equals to 3.